Lesson 23 is about graphical solutions. Our first example, what we need to do first is get the y by itself, so each of our equations are in slope-intercept form, and then wherever they intersect, where the lines intersect, that point is the solution for this system of equations. So with the first line they give us 3y minus 2x equals 6. I'm trying to get the y by itself, so I'm going to add the 2x to move it to the other side. So I'll have 2x plus 6 equals 3y. And I'll divide everything by 3. So y equals 2/3 x plus 2. Then I can go ahead and graph this. Let's see, it starts at 2 because that's our y-intercept right here. And then from that point it goes up 2 and to the right 3. So 1, 2, 1, 2, 3. That's our next point. And we can go ahead and graph the line from there. Alright, and let me use another color for the other line. Our other equation we're given is y plus x equals a -1. And on this, all I have to do is subtract the x on this equation to get the y by itself. So y equals -x minus 1. So here I'm going to start at -1 because that's my y-intercept. And then that -1 in front of the x is like a -1 over 1, so I'm going to go down 1 and to the right 1. And then we can go ahead and graph our line. Alright, I would say at this point right here, let's get a different color. This point right here looks like it would be my solution, which is, let's see, 1, 2, -2, 0. But we need to check our answer by using either substitution or elimination. Now, since I have the y all by itself down here, I'll just go ahead and use substitution. So I'll take this -x minus 1 and put it in place of this other equation. So I'll have 3 times -x minus 1 minus 2x equals 6. Then distribute my 3 across, so I have -3x minus 3 minus 2x equals 6. Right, I'll get my like terms together. That's a -5x minus 3 equals 6. Add the 3. And then divide both sides by a -5. Okay, so x equals -9 over 5. And then for my y, I just need to put that right back in here to find out what y is. Scroll down a little bit. So y equals -9/5 minus 1. That would be a positive 9/5 minus 1. And this would be a -5 over 5. So 9 minus 5 is 4/5. So y equals 4/5. So when we write our answer, it would be -9 over 5 and 4/5. So you can see that my graph was not very accurate. This is the actual solution. So I was in the right area, but it was not exact. Let's look at another example. Alright, so in this example, conveniently, one of our lines has already got the y by itself. and then we'll just have to get the first equation by itself before we graph. So for our first equation, y minus 2x equals 2, I just need to add the 2x on both sides. So y equals 2x plus 2. Okay, so I can go ahead and graph at this point. I'll go and I start at the 2, and then I'll go up 2 and to the right 1, up 2 and to the right 1. And I'll go ahead and graph my line. Okay, and then the second one, that is y equals a negative 3, so I go down to negative 3. And I'll change my color here. Alright, so this one appears to intersect about right here. So that would be negative 3, negative 3. Alright, let's see how accurate we are this time. When I solve, since this y I already know is negative 3, I'm going to put that negative 3 in for the other y. So negative 3 minus 2x equals 2. Add the 3 to both sides. So negative 2x equals 5. Divide both sides by negative 2. So x equals negative 5 over 2. And then y equals a negative 3, we already know. So it's negative 5 over 2. Negative 3 is what the actual answer is. So again, I was in the right vicinity, but I was not exact. So you have to make sure that you check your solution with substitution or elimination to make sure it is accurate or correct.